G'day everyone, my name is Mark BACHMANN and I'm the Managing Director of Nature Glenelg Trust, a not-for-profit organisation that works across southeastern Australia with a particular focus on restoration and the restoration of ecological processes. Now, if the program is rolling out as planned, you'll be watching this presentation just after afternoon tea, so I know there could be a few people sitting there relaxing and maybe with a full tummy. I'll try and keep you alert with a really interesting journey across a range of sites that we've been working at over the last 10 years of NGT's existence, and I'm hoping I can give you a bit of a taste of what it means to read the landscape. And when it comes to wetland restoration, this is extremely important to understand trajectory of change through time. So that'll be a real theme of our discussion today. Let's get started. First up today, I'm going to show you a place called Rowan Swamp, which is a couple of hours north of Melbourne. And the value of old maps. This is a really useful tool for us in piecing together the history of a site. So this map here was drawn by surveyors in the 1880s and gives us a pretty good idea of where the waterways and the wetland edge were. In terms of understanding some of the changes that can occur at wetlands, that old map was really useful for then comparing against the modern digital elevation information that exists, and that image there you'll see next to the 1883 image is what's called LiDAR imagery, which shows a really accurate representation of the land surface. And you'll see that outlet has actually eroded into the wetland edge, and we suspected that this was causing a reduction in the extent and depth of water that was being held in Rowan Swamp, which is the reason that we were invited to look at the site. Now, when you go out on ground, you'll find all sorts of interesting evidence of change, particularly when you've got really long-lived species like red gums, as you can see here, and those exposed roots, which tell us that the natural soil level in the vicinity of this eroded outlet definitely has fallen. Indeed, it's quite pronounced at the location of the former wetland edge, where we were finding roots that were exposed up to 1.5 meters below what was originally natural surface. So it's a really interesting thing to look out for when you're at a site where change is occurring. In terms of other tools, that LiDAR information is really helpful for building a digital elevation model of a site. And you can see the general shape there that matches the original wetland. We can use this to actually mimic what would happen as you fill a wetland from empty using GIS tools to model the inundation extent of a wetland, as you can see on the screen now. And this was a great way of us understanding at what depth would we get a wetland inundation extent that most closely mimicked the original wetland as drawn in the 1880s. And that allowed us to land on a target height for our proposed trial structure in the eroded outlet. And as you'll see, that would really closely mimic the original inundation extent. This mapping really helps us then target a location, but also obviously the height of a trial structure, which is proposed for this location now to occur and be put in place as soon as conditions allow. And trials generally have been a really important method for us to test our ideas, and they're adjustable. They allow us to understand the impacts of restoration before making permanent decisions, and also a really great way of involving the community, particularly in public land sites where there's a lot of interest and quite often a long-term desire to be involved in fixing some of these issues. Noting that many of these on the screen after a trial phase, and once we've gathered data about impacts, generally they're usually positive. Most of these sites you can see in front of you have actually progressed to permanent remedial works to remove the artificial drainage completely from the landscape, which is a fantastic outcome. Our second example, Tilly Swamp, is actually near a place called Salt Creek, which is a location where flows from the southeast of South Australia used to enter the Coorong, which many of you will be aware is also connected further north to the Murray-Darling Basin through the Murray River. And this is just a quick example of how valuable old accounts, journals, books, old photographs can be for piecing together the history of a site. There had been some conjecture about the frequency and the nature of flows from Tilly Swamp into Salt Creek and onto the Coorong, but clearly when you go digging through old accounts, you find these recollections of people about the conditions on site well before any modifications were made to the catchments in that area. These are really fantastic ways of piecing together history of a site. And old survey maps and diagrams, as we saw with the Rowan Swamp example, extremely valuable. In this case, there's notations on here which tell us not only where the the main watercourse and water bodies were, but the nature of the floodplains and the vegetation that's growing across them. Fantastic insights into early conditions. Of course, over the 100 years since, there's been all sorts of artificial hydrological changes, not just within Tilly Swamp itself, in the case here of artificial drains that have been dug through the system, but upstream and the diversion of flows through drainage of headwater areas as the agricultural development of the southeast of South Australia occurred. Interestingly, when you go out on site in places like this, there are all sorts of, again, evidence in the vegetation, and when you compare those old survey diagrams and the notations in vegetation which reflect a certain hydrology, and we look at the aerial photographic record, we see these trends of change that are being driven by hydrology and are now witnessed in the vegetation. So you'll see here a wetland basin in Tilly Swamp that literally before our eyes over recent decades has been shrubbing up with the invasion of, in this case, saltwater paperbark, which is a type of melaleuca, simply responding to the change in hydrology. And in fact, the drying out of Tilly Swamp had become so severe that there were coastal colonising species from the dunes, coastal wattle and coastal bearded heath here, also invading these formerly wet flats. Having said that, this is a happy ending, this story, thanks to a major government program to reverse the effects of artificial drainage in Tilly Swamp. The area that was still inundating, called Morella Basin there that you can see, as a result of previous changes to hydrology, has now been increased significantly with the regulation of drains and allowing for diversion of flows into the original wetlands. And so we're actually, this is a rare example of where we're seeing the capacity for re-inundation of a major portion of Tilly Swamp, about 6,000 hectares all up, which can now inundate when sufficient flows come into the system. This is the type of outcome that's possible when we're prepared to manipulate hydrology and, of course, gain the agreement of landowners along the way, which was a key sticking point in this case that threatened this particular outcome. Next example is a property that Nature Glenelg Trust owns. You can see the dashed line there. This is 1,000 acres of floodplain next to the Grampians National Park and two wetlands that we'd previously restored, Gooseneck Swamp and Brady Swamp, with community help. In fact, they were in the images of the community trial structures that you saw earlier. Take home from this is the elevation information there, but look at all the lines across Walker Swamp, the property there. Over 20 kilometres of artificial drains cut through the floodplain. This sort of information is critical for planning wetland restoration works. In terms of other things we consider, in this case, we also looked at modelling the effect of us regulating drainage inflows from the north and which infrastructure we might need to keep and which infrastructure in terms of drains we need to backfill. We retained a couple of levee banks to prevent flooding out neighbours, but before we did any of this work, we were able to again predict how flows would enter the site, where they would sit, what changes we would need to make, including lifting the level of a road there at number 5 and putting in culverts to facilitate flows passing through to the south. And this is a really helpful way of understanding the impacts of restoration before doing anything, because looking at neighbouring landholders, and in this case we had a farming neighbour, they're really happy with the project, but they didn't want us flooding them out. This is a really important thing to weigh up when proceeding with wetland restoration works. We had lots to do out there. This is a property that had been converted to blue gum plantations of all things. Drainage facilitated that land use change, so we had to remove and spray the coppice of those reshooting blue gums. We had a lot of work to do to remediate areas that have been furrowed and mounded for the planting of blue gums. And that's the trial structure there, which you can see the effect of literally backfilling drains by sweeping the spoil bank back into the channel, removing the blue gums, and we had a clean slate there in the bottom right, ready for restoration. In terms of what permanent restoration looked like here, sometimes we also use volunteers and sandbag structures in the initial phase of permanent works. This is the outlet drain ahead of sandbagging. This is the process underway. This is it complete with the drain backfilled upstream, and you'll see the sprayed blue gums there in the background. And in 2019, we had a partial filling event, not enough to fill the whole system, but we got a bit of a taste of how it would work. And as you'll see here, we had a decent rainfall event last October that generated sufficient inflows to fill the major wetlands at Walker Swamp for the first time in several decades, which was fantastic to witness. The other thing you'll notice here, the way we design our works typically is wherever possible for them to be set and forget, which means that we don't want infrastructure that needs ongoing intervention to be managed or manipulated. It allows for a site to really settle into and adjust to the new and ongoing hydrological regime and respond to climatic variability over time. What this has looked like from above in the aerial photographic record, and we're fortunate to have a pre-development image of Walker Swamp. You can see there, as we fast forward through time, you'll see the effects of land use change and changes to drainage. So here, basically up until 2014, the site had been heavily modified and artificially drained. We had the trial structure in place for 4 years from 2014, and you can see the effect that it had on static water levels in Walker Swamp. Partial restoration. This was in conjunction with the previous owner. After NGT purchased the property, we did the permanent restoration works but didn't get a complete filling that year, and the final image, you can see the amount of water being held up, which was off the chart really compared to anything that had happened out there for several decades. Another tool we can use, which applies to Landsat data back to the 80s, is called Water Observations from Space, or WOFS. And I'll just show you an example here of the type of information that can be gleaned from this. It's an Australian government tool. So here's an image of Walker Swamp in its drain state, showing the sort of water that could be retained over the summer months in 2011. This is from 2016, when we had the trial structure in place after a wet spring. And as you'll see, with full restoration, the amount of water that's been detected is really consistent with the image that you saw on the previous slide. And yeah, pretty excited to be able to show you this image of Walker Swamp as a result of several years of hard work. This property is not only back, but on a trajectory of recovery, which is going to allow it to continue to get better over time, which is one of the really wonderful things about wetland restoration. Now, just a really quick example to show you how wetland restoration can also occur, and we've had great success on private land, including sites that have been heavily modified with, even in this case, the soil being tilled. After restoration, once you hold water across the land, you actually give the competitive advantage to any residual wetland plants, their seed, their propagules, their roots, rhizomes in the soil, to take advantage of those recovering conditions. It's a bit like breaking the artificial drought. This site, only 3 years later, complete transformation, not necessarily in its original condition, but fantastic bird habitat and plant communities that are continuing to improve and evolve in response to the recovering conditions over time. Our final example today is down there in Tassie on the east coast near Swansea, the Apsley Marshes and Moulting Lagoon, which, as you probably all know, is an internationally significant wetland. The image you can see there is just our initial take on the earliest drainage, which predates aerial photography. So those black and white images are what we've used to be able to work out what drains were in place at the time of the first aerial photography. Zooming in on part of the site that we've begun the investigation at, and we're progressively working our way around the site. This is a Tasmanian Land Conservancy property, in fact their first reserve, called Longpoint. And you can see there at the time that the property was purchased by the Tasmanian Land Conservancy, they inherited a legacy of artificial drainage impacts, and we've sought to try and understand exactly what the purpose of those drains were. In the course of mapping the drains, we came to realise that in fact what we initially thought were drains looked like they were in fact, the oldest ones were in fact a levee system designed to prevent inundation of that area that you can see hatched there of about 80 hectares, which very long time ago, the landowner was clearly trying to keep water off that area and allow it to produce better feed for grazing livestock. So sometimes what first looks like a drain is actually something else. The drain was the void left behind when this levee bank system was constructed. There were more recent drains built to the south there. Quite a small footprint in area, but of the actual works, but the wider zone that such works can affect can end up being quite large. Thankfully, the remedial works required can actually have a pretty small footprint. Once you've swept the spoil bank back into the void or drain, you're left with a relatively small footprint, but can affect a much wider area, as this example from south of Adelaide at a place called Glensheera Swamp shows, where we've had a really fantastic result, which will continue to get better over time as a result of having backfilled that drain. And at another part of the same site, where we've also backfilled drains, you can see here an example of how undertaking those works have not only created a space for recovering native vegetation to respond, but the underlying hydrological conditions actually mean that response is going to really take off and have the greatest chance of success. In this case, we've resaturated the peat profile. Today, we've just scratched the surface, but I'm hoping that it's given you a really clear understanding of how anything that impacts on the way water interacts with the site will have a flow and ecological impact. And depending on when we come along and see the impact of those changes, we may not even recognize that they're taking place. So the take-home message for you today is you do have to be prepared to intervene when we understand that these past effects have been causing this trajectory of change, which is unfolding over time. We do have this unique opportunity when it comes to water in particular to be able to work with ecological processes and drivers. And with water in particular, we have this, it's a magic ingredient. You know, when you fix the way the hydrological regime works, you can trigger self-sustaining recovery, which really makes it stand apart from a lot of the other challenges we face with environmental management. Just a final couple of images to show you what inspires me. So, you know, this is the very first large-scale wetland restoration project I was involved in a former life, a place called Pick Swamp near the South Australian-Victorian border. And that's my boys wandering across the day we went out there to watch the wetland refilling for the first time in several decades. Now, this site, all these years later, is part of a Ramsar site. You can see it used to be farm paddocks, and today it's an amazing and transformed place. And this is the sort of outcome that is possible across our landscape if we carefully identify sites and get on with the job. Thank you very much for listening, and yeah, my contact details are there if you're interested to get in touch. If you have a drained wetland anywhere in Tassie and you're interested in our insights or advice, we'd be more than happy to talk with you. Thanks very much.